Node.js streams are in the Node.js core since the first versions of the platform. In this class, I will speak about Node.js streams, but you can relate it to web streams as they follow the same paradigm. They are commonly used for on-demand data processing, proving that Node.js can handle big loads of data processing. JavaScript, as you may have heard, wasn't made to process too much data in memory at once. If you load a 2 GB string in memory, the platform will crash and warn you that you've exceeded the memory limits. Well, Eric, then it's better to use Python to process large files, isn't it? If you're a JavaScript developer and want to process big loads of data, want to download files on demand, or process big reports across many spreadsheets, then let me present you to the Node.js streams. Today, I'm gonna show you in practice what are and what is the Node.js streams purpose. In summary, the Node.js streams are functions to help you process big amounts of data on demand. Imagine that you need to process your company's annual sales report. You wanna average your company's and affiliates' gross income, process taxes, aggregate all business intelligence data, and plot it on a dashboard. As I mentioned at the beginning of this video, a 1 GB file in memory is more than enough to break the Node.js or slow down your browser. Then you can assume that you cannot just read a whole file and put it in memory at once. Now imagine that instead of processing the whole report, you're gonna process it on demand. You paginate and gradually process items every 10 lines of the report, for example, and at the end, you generate the final amount. Looks better, isn't it? In this way, you can even think that beyond making your company's gross income, you can make the annual costs report, employee salaries report, and much more. And processing everything without worrying whether the Node.js will be able to process or not a whole load of data. Assuming that you are gonna process data from now on demand, it doesn't matter whether your file is 10 kilobytes or 10 terabytes. You gradually read and process your data. Bringing it to the Node.js vocabulary, Node.js creates an internal buffer, an object with 2 GB size at most, and split it into small pieces of 16 kilobytes. If the data source you are handling at the moment is bigger than 2 GB, Node.js will try automatically consuming the first gigabytes buffer, discard it, and reallocate the remaining data into another buffer. Those small pieces of data are also called chunks. Node.js triggers events saying that the data is available, our function consumes, and then calls back the stream saying that it's available to consume more data, and so on. You see, it doesn't matter whether the file is 1 kilobyte or 1 terabyte. As long as Node.js is controlling the flow between the data coming in and the data coming out, processing it on demand, we can process without worrying about CPU or memory available in the machine. This powerful system is what helps us to scale Node.js servers with using very few resources. And as I said before, it works using the system since the first version back in 2009. Crazy, isn't it? Bringing it more to our world, imagine a golden nugget. This golden nugget is in the solid state. You've melted down this golden nugget to transform it into the liquid state gold. You then spew the liquid state gold into a filter channel, added chemical products, and etc. When the gold starts going through the filter channel, you have a stream gold. When the gold starts going through the filter channel, you now have a stream of gold. In other words, you have a liquid flow going through each processing step. Instead of processing a whole ton of gold, you've reduced it into the liquid state, and now you can do it in liter portions. That's it, my friend. A ton of gold turned out into liters of gold, or in our case, chunks of gold. That's amazing, isn't it? As I said, this liquid state gold got into the funnel. Then the funnel will be the one who's our data source for our processing. In Node.js strings, the one who's the data source is also called readable strings. After the liquid went through the funnel, it got into the first processing step. a step meant to clean all impurities on the liquid state code. In Node.js streams, the step to map or clean data to get only what's needed for the process or even parse it into another format is called transform streams. For now on, adding acids or mixing other chemical products, each one of those additional steps are also transform streams. Finally, it's time to transform the liquid gold into something else. Now, you're gonna drain it to another step. Each chunk or each liter of gold will become a small golden nugget and gets out of the pipeline, finishing the process. The last step before ending the pipeline to make the actual final product in Node.js streams, it's called writable streams. Just think of it as whenever you need to print any data on the screen, save data on a file, or make an upload to an external source, anything that represents the final step on your pipeline is a writable stream. These are the main concepts you know to use both web and Node.js streams in practice. So let's summarize it. A readable stream is a data source, a database, a file, a web request, or any data source you're gonna consume. A transform stream is used to convert data, filter, or map objects. In the end, it's just a refining step that will pass through data to another processing step. A writable stream is usually the final step. For each item on your data streams, it generates the final output of your item. The final step could be a console.log, an external database, a file, a web API, another stream pipeline, or more. Well, think of me. Your file was reduced into little pieces of data, and each piece or chunk will run throughout each processing step as a funnel. This funnel with processing steps in Node.js streams are called pipelines. If you work with Node.js to build web APIs, you've probably used Node.js streams uncautiously. In the Node.js HTTP modules, the request object in your API is a readable stream, and the response object is a writable stream. The request object receives data from a user, and the response object outputs data to the user. If you came out from some data processing area, you may have heard about the famous extract, transform, and load steps, or simply ETLs. They are other names for our readable, transform, and writable streams. If you're still not sure of what scenarios you could use Node.js streams, the most common use cases are for writing and reading data from big data sources such as files and databases, processing big reports and spreadsheets, audio and video processing, ETL processes, anything that can be gradually written or consumed. Yeah, my friend, welcome to the Node.js streams world. With it, you can do a lot and really feel the real power of the Node.js platform. In the next class, I'll code with you some examples showing common problems while reading files and how is the best practice to handle massive data in Node.js. Don't forget to evaluate this class by clicking on the star below, and if you have any questions, use our comments sections or our Discord channel to discuss it with other students. I'm sure they would learn a lot from your questions and would love to chat with you. I'm always available to chat with you on our Discord channel. Use it as much as you can. There are a lot of people switching jobs because of the opportunities they've been receiving there. I hope this class has exceeded your expectations. I'm Eric Wendell, and I'll see you on the next video.